Okay, well, thanks for coming out on Saturday morning. As Jeremy said, I'm Bennett Davis, and I started my career in medicine actually as an EMT in San Diego. That's why one of the Tower Challenge connections. But I started my career as an orthopedic surgeon doing orthopedic surgery residency in New Mexico after medical school. So I started, very medically oriented. I have a bad back and I couldn't stick with that, so I couldn't stand in the operating room long enough to make that career work, I think. So I switched to sports medicine, pain clinic, chronic pain clinic. I was recruited to come here in Tucson in 1995. That was to run a new pain clinic, help set up the cancer center, which needed a pain program. So I had a mandate to get all the departments working together, playing nice together, which was really kind of fun and difficult. So I did that for 7 years, went into private practice. The group of us from the university, psychologists, but by the time 7 years had passed, we had a behavioral health team, we had nursing, we had physiatry, neurology. We all moved into private practice at the Integrated Pain Center of Arizona here in Tucson until 2 years ago, which is when I went to Sierra Tucson. So that's kind of my background. So I was telling you that because I started in orthopedic surgery, kind of got transmogrified into this blend between medical person and behavioral person by working with behavioral health people for a very long time. And that taught me a lot. And I'm working with chronic people with chronic pain. So that's kind of my path into here, because most folks with chronic pain have depression, anxiety, a lot of things going on. There's a lot of substance abuse in that group. And you have to learn to recognize all that. So I've built up my skills in all those different areas as time goes on. Before medical school, I thought I was going to be a marine biologist, so I was a neuroscience guy. I was at Scripps, oceanography, all that stuff, and studying neuroscience, so studying in the lab, stuff like that. So I have a little bit of background with the rats in the lab and the neuroscience. Arizona, one of the reasons I came here is, I don't know if you know this, but University of Arizona has one of the top 4 or 5 in the world neuroscience labs for studying pain and addiction here at the University of Arizona. And we're just finally, after 20 years, getting the Center for Pain and Addiction started here at the U of A, which is going to be a big deal, funded and so on. But they have 20 postdocs, about 10 real top-level PhD people studying pain and addiction at the university. So, and I hang out with those people still. So what I'm going to tell you here is informed by my journey through both neuroscience, kind of that pain door into addiction, substance use, and that sort of stuff. So it's Saturday morning. I'm going to give you a little bit of rat science. Is that okay? A little bit, just to kind of tune things up. So what I'm going to talk about is just kind of the biology behind what addiction is. And I'm going to disclose right up front, talk to the best of the best in the world in neuroscience. We don't know. That's really it. We're learning a lot. The tools of the biochemical tools, the science, basic science tools that we have are evolving so fast in the last just 5 years that we're going to know a whole lot more 5 years from now, just a couple of years from now. But we have sort of like little windows into this black box as to what addiction is. And I'm going to give you kind of as legitimate a tour through some of that stuff as I can. So it turns out that in our brains we have circuits, I talk about circuits a lot, we have circuits that are there to give us a pat on the back when we do something good. So why would we want a pat on the back? We find food, water, sex, etc., things that are good for us, our survival and survival of the species. We've got a circuit in our brain that says good job to motivate us to do what? Do it again, go find food, have more offspring, keep doing it. That we have that. That is the circuit that addiction touches. That's the circuit. So that's what I'm going to be talking about. That's why it's there. It's there for survival reasons. And it says up here, can you all see the bottom of the slides from the back? It says the completion of each successful goal leads to a rewarding stimulus that further reinforces the behavior. So that's what it's for. Keep coming back. And where is this thing? So I promised you a little bit of neuroscience. Here we go. So here's a picture, a slice through the brain. That's hard to see. And it's showing two parts of the brain. I'm going to give them their names, their formal names. The ventral tegmental area, ventral tegmentum, or VTA, here. Kind of, that's the brainstem right here. That's the front, the back. Right there. And the nucleus accumbens. This is kind of the most important one right here. This part of the brain has little nerve sprouts that talk to that one. So, you know, nerves are kind of like an octopus. You have the nerve cell like the octopus head, and then the arms of the octopus reach out and touch other animals. Well, in the case of nerves, nerve cells here have these little arms that go out and can communicate with other cells that are here. That's what I mean by a circuit. You've got one part of the brain communicating with another. So this part of the brain has connections to communicate with this one. And we're going to go into a little bit more about how that works, but I just wanted a real simple picture to introduce those two areas of the brain to you. So, how do we know that these two, in particular this one, nucleus accumbens, is kind of the reward center? How do we know that's the reward switch? If you wanted to design an experiment, I gave it away already, what would you do? You'd get a rat in a cage, and you put a little electrode, and you'd stick it right in there, and you give him a little electricity and see what he does, right? All right. There he is, as promised. So this is 1954. This is where we got our ideas about what addiction is, from these kind of studies. And some of them weren't really correct, and I'll get back to that. But anyway, we were wondering, okay, you know, we know about risk reward, that's going on. Where in the brain is this happening? Where are the circuits? So rats got the little probes down into different parts of the brain. This is a probe into that thing right there, the nucleus accumbens. So that's where the stimulating electrode is in this guy. So the setup of this experiment was very simple. Cage. Notice anything else in the cage? Nope. No distractions. No distractions in there, just a lever. When the rat pushes that lever, it sends a little electrical current down into the electrode, into the part of the brain wherever the electrode tip is. So this rat is able, this one is able to stimulate, oh, where'd he go? Is able to stimulate this part of the brain and none other. It's just a little tiny current. So what we do is we measure kind of what the rat does. And it turns out if you put the electrode, oh, say, over here, or over here, or over here, and you hook it up so that when they push the lever, they give themselves a shock. The rat ignores the lever. When you put the lever here, the rat will push the lever and do nothing else until it falls over from dehydration. It'll just sit there and push the lever because apparently it likes a little stimulation right there. So that's how we figured stuff out. We also found that the rat will preferentially sit there and just push that lever the most when the electrode is in the nucleus accumbens, and also in the ventral tegmentum. So it really likes this the most, and then this too. So that was a landmark experiment saying, oh, now we know what part of the brain is involved in the reward system. We didn't really know how it worked yet. And I've got to tell you that we did the same thing. I didn't. Somebody did the same thing in people. They got people to electrodes in the brain. I don't know who signed up for this, but people did. And they looked at the region stimulated and how many presses, same thing, sit in a chair and just press a lever and tell us what it feels like. But press the lever as often as you want to. There's no restrictions. Just sit there and press the lever and, here's a cup of coffee, here's a donut. Do whatever you want, but press the lever as often as you want. And they measured how many presses per hour, how frequently the person went at it. And also took some notes. So here's a part of the brain that's involved in emotion. That's a lot. And people said, feels pretty good, give me some more juice. Can you turn it up a little bit? I'm feeling happy. This was sort of a happy center. But what I wanted to show you is, look what happens when they put the electrode in the nucleus accumbens. The subjects in the experiment would press it every 10 seconds until you turn the juice off. Actually, they didn't want to stop. It was like, you're pulling them away from the lever. So this is the same study in human beings, believe it or not, that's showing that this area of the brain is the reward center. That's the feel-good reward center. Do you guys see what this says? What they said? People said pressing the lever. You can't see over there. It says feel great sexual thoughts. They're like, woohoo! They really liked that lever. This one also was pretty good. Drunk feeling happy button. So that's how we know about this circuit, the risk-reward circuit, just so you know where this all came from.